Hello friends, welcome to Dr. Ossai Physiology Academy, DOPA for short. This is the place where we make the learning of physiology easy, exciting, and effective. Thank you for joining me. If you're new to this channel, you're especially welcome. Alright, so if you love the content that we share, kindly click the like button, the subscribe button, and turn on notifications so you don't miss any new content we drop. Alright, so let's get right into it. Now, gastrointestinal motility. We are done with the introduction that will form the foundation for understanding those 4 basic functions of the gastrointestinal tract and digestive system. Motility, secretion, digestion, absorption. All right? So motility, we are going to be dealing with the motility of every part, every segment. We said that the GIT has compartments separated by sphincters. So that's how we're taking every part of it in the different functions. Okay? So we'll start with motility of the mouth, in the mouth. But before we do that, let me just take your mind to something very important that you just need to know. Okay? That to generate this motility, okay, there are waves, electrical impulses that are generated in that enteric nervous system that we said can function on its own without the help of the extrinsic innervation. All right? So to get an understanding of what I'm saying, visit the part 2 of the introductory lecture to GIT. Look for it and watch. Okay? So what happens is that the impulses released that helps in contraction, secretion when they are activated and so on, they can be generated spontaneously. You know, something like, just like the heart. The heart has what they call a pacemaker that generates action potentials by itself. It doesn't need anything to stimulate. It just generates. Just that the parasympathetic and sympathetic part of the autonomic nervous system can influence it, slow it down, or make it beat faster. Okay? Make it faster. But by itself, it has a way of generating impulses in a rhythmic manner, off and on, off and on. Similar thing happens in the GIT. Okay? So just like you have the pacemaker cells, there are cells in the GIT. They are called interstitial cells of Kajal. They function like pacemaker cells. They are responsible for the rhythmic contraction and relaxation of the smooth muscles of the GIT. And they vary from the different segments, from sometimes 3 contractions per minute, sometimes as much as 8-9 contractions per minute. Okay? So 3 to, let's say, 8 or 9 contractions per minute. So they have 2 kinds of impulses that are generated in the enteric nervous system that leads to motility and so on. Okay, one of them is called slow waves. Number 2 is called spike waves. Okay, the slow wave is also known as the basic electrical rhythm. All right, BER for short. So these slow waves, they generate impulses, but they are not, those impulses electrical, they are not action potentials. They are not. Right? So those impulses they depolarize the nerves there. Okay, so they can take it from the resting membrane potential for this enteric nervous system is around 55 minus 55 millivolts. And you all know that usually for action potential to begin, it needs a threshold, which is usually about 15 millivolts additional to this one. So when you add 15, you get minus 40. Okay? So this is the threshold. Threshold. So it depolarizes, but it may not lead to action potential. But once it depolarizes to the point where it reaches 40 millivolts, it leads to action potential. That action potential is what is now known as the spike wave. This is the action potential. Okay? So that's just background knowledge. So you need to just know that basic electrical reading, spike waves, slow waves. Okay? So now let us go into start from the mouth. Motility in the mouth. Now, there are two things that happen. One of them is chewing. When you put food, the first thing that happens is that you chew the food. What's the next thing that happens after chewing? You swallow. So we're going to be dealing with chewing and swallowing. Chewing and swallowing. Now, this chewing, in the normal medical term, physiological term, we call it mastication. Mastication. Swallowing, we call it deglutition. All right, so let's start with mastication. So, mastication. Now, mastication is a physiological process. And physiological processes, the effectors are what? Muscles, glands. But in this case, obviously, they are controlled by muscles. Chewing. You're chewing like this. That's it. So you have muscles of mastication. You have muscles. So mastication is controlled by what? Muscles of mastication. I'm sure you know that from your anatomy. Okay? Masseter is the very common one. Pterygoid, temporalis, and all of that. They are skeletal muscles, very powerful muscles. When you bite, you can bite someone's hand and even break the bones. That's with your teeth. Very powerful muscles. What do? So what is the purpose? First of all, what is the purpose of mastication as it relates to the function of the GIT? Now, one, the obvious function that you should not forget, it's the grinding. Very powerful. For example, you can't just take a lump of meat, piece of meat, and just swallow it. You're going to cause a lot of work for the rest of your GIT because they don't have teeth. This teeth is very powerful to do the major work of grinding. Okay? Grinding and breaking down large chunks of food and breakdown of food particles. Okay? Does a lot of that. That's mastication. Another function of mastication, as you are chewing your food, your saliva is being secreted. So that grinding helps in the mixing of food with saliva. Okay? Then another important function of mastication as you are chewing your food. That saliva in itself has a digestive function, but that's for carbohydrates. So it helps that chewing of the food and the mixing. So it helps in the initial digestion of carbohydrates, COH for short. Okay? Then another one is that saliva in itself also has lubricants. You know what called lubricants? Lubricants are things that when you rub it on something, it reduces friction so that it can easily move and slide over another surface. So that saliva does what? Lubrication of food. Lubrication of food for easy swallowing. So those are the things that are happening. And another fifth one, very important, very, very important, appreciation of the taste of food. So this appreciation of taste of food, it looks trivial, but it's very important in ingestion and nutrition. Why? Because if the taste of food is bad, most times you will not eat it. Do you understand? So your chewing is what gives you, just like taking drugs. Most of the drugs you take, you don't chew them. Why? Because they are very bitter. If you say you want to chew them, you will spit them out. So this chewing helps the appreciation of the taste. It can make you eat more or make you eat less. So chewing, look at very important 5 functions of chewing. Now, let us now look at some of the mechanism. Now, you can stay and be chewing your mouth voluntarily, as with conscious effort through your will. But mastication in itself, in its ideal self, it's involuntary. That's why you can be watching a movie and your mind is totally focused on the movie. And you are eating, you are chewing. But you are not consciously chewing at that moment. It's involuntary. So how can you be closing your mouth, opening it, contracting your muscles without you knowing, consciously doing it? It's a reflex. So, and all those reflexes, they are controlled, starts first. Receptors. Afferent, efferent, and all of that, effectors. Of course, you know the effectors are the muscles of mastication. Okay, so let's just briefly touch that. The reflex. What happens? When food enters the mouth, there are stretch receptors. Remember I said that food, the volume of food itself can stretch the GIT. So they sense that stretch, mechanoreceptors, stretch receptors in the mouth. And what happens? They inhibit. So immediately, first of all, when food enters, the first thing is that there's inhibition. Inhibition of muscles of mastication. Okay? So when there's inhibition of the muscles of mastication, the jaw drops. But when the jaw drops, it stretches another set of mechanoreceptors. So there are 2 different sets of mechanoreceptors. This first one inhibits the muscles of mastication, which makes the jaw drop down. The jaw dropping down activates another set of stretch receptors which contracts the muscles of mastication and it closes the mouth. As it closes the mouth, what happens again? This other one is activated, which leads to inhibition of, so there are two different kinds of stretch receptor that work in opposition to each other. One is inhibiting the muscles of mastication. One is activating the muscles of mastication. The action of this one will lead to what will activate the next one. The action of that one leads to what will activate. So it goes off and on. Chewing, open, close, up, down, up, down. All right? So the next set of receptors leads to stimulation of the muscles of mastication. So that's just how it happens. The receptors, then the nerves there, mainly the mandibular branch of the trigeminal nerve, they supply those muscles of mastication. Okay, so that's what you need to know. And where is the control center? Every reflex, okay, control systems, they have a control center. So because mastication has a voluntary aspect, I can decide to open my mouth and close it. That means it's my cerebral cortex. I'm using my will, voluntary. So the control centers can be one, cerebral cortex. Number two, the part that controls the involuntary aspect is the medulla. Medulla oblongata. All right. So this is what you need to know about mastication. So you have a chewing center in the brain. You also have a chewing center in the medulla. So next, we're going to be dealing with swallowing. All right, which will make us conclude the motility in the mouth after this break. Right, welcome back. So we're now going to deal with the second part of motility in the mouth. Now, the muscles of mastication in combination with the teeth and the tongue, they've helped to chew the food and chew and chew and roll it around and chew, mix it with saliva. Now, that food is now converted to a ball by the tongue. The tongue rolls it into a ball, which is called, like I mentioned before, bolus. Bolus of food. So this bolus of food will now be swallowed. So how can we define swallowing or deglutition? Can we define it? All right. So deglutition, swallowing, is the movement of bolus of food from the mouth to where? To the stomach. Some people can make the mistake of saying movement of the food from the mouth to the esophagus is swallowing. No. From a physiological point of view, is the movement of bolus of food from the mouth to the stomach. And I'll tell you why. So don't get confused that, oh, when you swallow, once it passes your throat, you have swallowed. That is layman knowledge. It's from the mouth to the stomach. That's deglutition. Deglutition is complete when the food has now entered the stomach. Okay? So, it's a very complex process. But we'll make it easy by just dividing it into 3 parts and then looking at the basic activities that happen in those 3 parts. We call them stages or phases of deglutition. One of them, you have the oral phase or stage. Then you have the pharyngeal phase. And number 3, the esophageal phase. That's in order to which they happen. Okay? The oral happens first, pharyngeal, esophageal. Okay? So, now what happens in the oral phase of deglutition? The bolus of food has been formed. Now, this phase, one important point you need to know is that it is voluntary. It is controlled by skeletal muscles that help to push the food. So this voluntary phase, when we want to know the whole of deglutition, is this movement from mouth to stomach. So oral phase is from mouth to pharynx. Pharyngeal phase is from pharynx to esophagus. Then esophageal phase is from esophagus to stomach. All right. So, like we just said, this oral phase is voluntary phase, and it's the only voluntary phase. Okay? These two, this and this, they are involuntary. Once you pass this phase, there's nothing you can do to stop the food from being swallowed. All right. So what happens in this phase? So that you will not be confused. There are important points you just need to note. And the key effector of this phase is the tongue and the pharyngeal muscles. So the tongue does what? First of all, one action is that it transfers the food, transfer of the food. It forms the bolus to the posterior part of the tongue. Transfer of food to posterior tongue as the back of the tongue. And the next thing that happens, that's oral phase, is elevation of the tongue. Elevation of the tongue against the hard palate. The hard palate, that back roof of the tongue, the hard palate, elevation of the tongue. Then see retraction of the tongue. These two, they happen almost the same time. Retraction of the tongue. So it's voluntary. All these things, they are voluntary. You can control them. You can control the transfer of food to the posterior part of your tongue. Elevate. No, the tongue itself is a muscle. It's a skeletal muscle. Okay, you can move it voluntarily. Okay? Against the heart, there are retraction. These three things push the food from the mouth to the pharynx. From the mouth to the pharynx. So this is what happens in the oral phase. So once the food has entered the pharynx, it's no longer under your control. Okay, the autonomic nervous system and the swallowing reflex takes over. Reflexes, okay, they are controlled by centers in the brain. There's a swallowing center in the medulla. It's involuntary. Medulla. Anything that is not in the cerebral cortex is involuntary. If it's in the cerebral cortex, then it's a conscious effort. So this part is controlled by the cerebral cortex. Okay? You can control all this because the tongue, which is the main effector of this oral phase, is skeletal muscle. You can move your tongue as you like. All right. So now we enter the pharyngeal phase. This is where it's most complex. The pharyngeal phase. And why this pharyngeal phase is complex is the fact that there is a connection between the back of your mouth, or let's say the connection between your mouth and your nostrils. True or false? Now, if someone is smoking a cigarette and takes a puff of smoke through the mouth, the person can bring it out either through the mouth or through the nose. I'm sure you've seen that. That means there's a connection between the mouth and the nose, between the respiratory system and the digestive system. So you have what you call the nasopharynx, oropharynx. So the pharynx is that connecting point. So you have the nasopharynx, the part of the pharynx that connects to the nose, then the part of the pharynx that connects to the esophagus. Okay? So food in itself, if care is not taken, can move, instead of to the esophagus, can move into the trachea. Food can also move upwards into the nasopharynx and come out from the nose, especially if the food is very watery. Of course, eba can never come out from the nose, but something like soup, tea, and all that, okay, you don't swallow well, it can choke and come out from your nose. So that pharyngeal phase is very sophisticated in order to prevent whatever you are swallowing from going the wrong way. That is the major function that you think about when talking about this pharyngeal phase. All right? If you close your nose, you can breathe through your mouth. So instead of air going from your mouth to your esophagus, it can go from your mouth to your trachea, to your lungs. So you see all this connection. So that means the points where food can pass, but it is not supposed to pass there, need to be closed. In this is where it happens. Pharyngeal phase. So whenever you're talking about the pharyngeal phase, just remember that number one, let's use this red pen. Food can go to the nostrils through the nasopharynx. So number one possibility is from mouth to nasopharynx and into nostrils. Okay? Number two is that food can go to the trachea to now pass from the pharynx to the larynx. So it passes from the mouth to the larynx to the trachea. When you call that aspiration, food content moving from your mouth and enter your lungs to cause inflammation problem for you and cause pneumonitis, that's inflammation of the lungs. Okay, it can pass through this. Then the third part, which is the desirable route, is from mouth to esophagus. Okay? So this is where we want. So that means the pharyngeal phase blocks this route and blocks this route. So how does it do it? So when the food has come from this oral phase, that the tongue has pushed it into the pharynx, there are receptors there. Okay? There are receptors that are activated and send message to the medulla, which is the control center. And medulla now sends back efferent impulses to control the closure of these passageways. So what happens? This first one, look at what happens. Prevention of this to the nostrils is that there is the soft palate. There's a part of that, the back of your throat that's called the soft palate. The soft palate moves up to close the nasopharynx so that food does not come out from the nose. Okay? So the soft palate moves upwards. That's what happens in order to block this one. So the next thing that happens is that this one, to close that larynx, the vocal cords, they close. A, closure of vocal cords. Okay? Number 2, B part of this one, this action, is the upward movement of the larynx itself. Upward movement of larynx. Okay? Then the third action is the backward movement of epiglottis. I will finally close everything. C. Backward movement of epiglottis. Okay? So just note that. Once you arrange it like this, it's easy for you to remember. There needs to be closure from the root to the nose. There needs to be closure of the root of the second root to the trachea. Okay? So this one, soft palate does that by moving upward. This one, vocal cord closes, upward movement of larynx and backward movement of epiglottis. So it closes those two roots so that there's only one root that should happen to the esophagus. So the next thing, this third one, what happens? The action of these two, the combined action of upward movement of soft palate and the upward movement of larynx and all this, naturally, automatically opens the upper esophageal sphincter. So there's no special opening of this sphincter. These actions here from this number 1 and 2, okay? The soft palate going up, this one going up and backwards, opens up the upper esophageal sphincter that separates the mouth from the esophagus. Then the food that has been pushed from this oral phase now enters the esophagus. So this and this is now complete. All right? So the next thing now is the esophageal phase. It's very easy. There's nothing really happening there. The food has entered the esophagus. So it's the force that pushes it from this oral phase goes ahead to push the food from the esophagus down. And what controls that is what is known as the primary, where will I write this now? Okay, primary peristaltic wave. That's what moves it. Primary peristaltic wave is from the force of this oral phase pushing it. But something happens. Sometimes this primary peristaltic wave is not strong enough to push the food from the pharynx down to the stomach. So there's another one called the secondary peristaltic waves. And this secondary peristaltic wave is activated by the continuous distension of the esophagus. So what happens at the terminal end of this deglutition is that once the food gets to the end, you have upper esophageal sphincter. That's the pharyngeal phase opens it up. Then the end of this esophageal phase now opens up the lower esophageal sphincter, LES, or if you write esophageal in the British way, LOS, esophageal sphincter. Okay, right, so once it gets there, it automatically opens the lower esophageal sphincter and the bolus of food enters the stomach and then it closes back. So that is the end of deglutition. Deglutition is said to be complete when the food moves from the esophagus now into the stomach. All right? So that's all you need to know. It's not easy. Just go over it systematically. Oral phase, pharyngeal phase. This is where it's a little bit more technical because of these things. But just know that there are different ways, different routes the food can pass to the nose, to the trachea. And for us, pharyngeal phase to be successful, it must close. So you just need to know what it does to close up those places, and you are done. This one, primary, secondary. And whenever they tell you to write any essay on deglutition, it's easy. All right? So I've written a book on gastrointestinal physiology. You can check the description box for the link. Just download it and go through it for further reading. All right? You can also check out our website. There's a link there in the description box where you can see a lot of things we do to make the learning of physiology easy, exciting, and effective. All right? So see you in the next video.